This video is a key to the Unit 1 Exam 2 Formative Assessment on Skills 5 through 10. So right off the bat here we've got a little bit of review of past topics. Again, while these questions will informally be on the assessment, it is skills that we should still be accountable for and the sort of things that can be embedded in other problems. First question asks us for the secant of 4 pi over 3, so I'm going to start by thinking about this as the cosine of 4 pi over 3. 4 pi over 3, I know that is going to be 240 degrees. So now if I think about that in terms of the x-coordinate, I've got an x of a 1/2. So since it's in quadrant 3, it's going to be negative 1/2. So the secant's the reciprocal, so that's going to end up being negative 2. 3e to the natural log of x squared. What they want me to remember is that e and natural log are inverses. So I end up with 3x squared in this particular case. 4 log base 4 of 64. Very interesting problem in that everything here is of base 4. But 4 to the log base 4, again, those are inverses. They eliminate each other, and I'm left with 64. Next, looking to evaluate the limit. If I try to evaluate this directly, I get 9 plus 3, which is 12, minus 12 on the top, or I get 0 over 0. I do see in this case, though, that this is going to easily factor for me to an x minus 3, x plus 3 on top, and to an x plus 3, x minus 3 on the bottom. Let's see here. Excuse me, it factors to an x minus 3, x minus 1 on top. Get rid of that. Go back to my pen. X minus 1. So now my x minus 3's cancel, and now if I plug in 3 to that limit, I get 2 over 6, or 1/3. Okay, moving on, we'll take a look at the next question as soon as the screen unfreezes here. Hopefully that's sooner rather than later. Still trying to move the screen here. Let's just let me write a bit. There we go. Come on. Come on, let's move here. Okay, the next problem we are taking a look at the sine of negative 11 pi over 6. Negative 11 pi over 6, I can think of that the same if I add 2 pi to that. That's the same as the sine of pi over 6. Sine of pi over 6 is going to be equal to 1/2. Okay, next question. Let's see here. We are looking at 3 log base 3 of x cubed, as was seen with the prior problem. With 4 log base 4, the log and the base cancel, leaving with just x cubed here. The limit at infinity, thinking about this as a horizontal asymptote. And therefore, I'm only going to look at the highest degree terms, negative 2x cubed over x cubed, or negative 2 there. And then finally, I see in the bottom problem, again, if I plug in 4 directly, I get 1/4 minus 1/4, or 0 over 0. So, could I use my definition of the derivative, f of x minus f of a over x minus a? Well, in this case, I have the 1/4 first, so I'm going to instead use the algebra, get a common denominator there. So I've got x minus 4 over 4x over x minus 4. X minus 4's cancel, leaving me with 1 over 4x as x approaches 4, and I get 1/16 there. Okay, moving on to page 2. So this is a review of skills of problems that we had already previously worked through. So some of our skills from 1 through 4, the first third of this unit. First question asks us for a derivative. No problem. We're going to use our various power rule scenarios here. So I'm going to get 10 thirds, x to the 4th, minus 7 halves, x to the 5 halves, minus 4x to the negative 5th. So there's a first derivative. Problem though asked for a third derivative, so let me go through the process again. I'm going to get 40 over 3 x cubed minus 35 over 4 x to the 3 halves plus 20 x to the negative 6th. And now last but not least, I'm going to take a third derivative, and I'm going to get 40x squared minus 105 over 8 x to the 1 half minus 120 x to the negative 7th. And there's my answer for that problem. The reason I'm bouncing between pages here is I'm seeing some issues, and when I zoom in, it's getting locked up. Part B asks me about a horizontal tangent. Okay, no problem. I know tangent means derivative. I know horizontal tangent means derivative equal to 0. So then I'm going to set 6x squared minus 6x minus 12 equal to 0. Factor out a 6 and I get x squared minus x minus 2 equals 0. So now I can factor that into x minus 2 times x plus 1. That's equal to 0, and now I get the following: x equals 2 or negative 1. So those are the, now it said it wants the points, so now I'm going to go back to the function. So f of 2 is equal to 16 minus 12, that's 4. 4 minus 24 is negative 20, plus 20, so that's 0. So one of the points is at 2, 0. Then I'm also going to plug in negative 1, and I get negative 2 minus 3, that's negative 5, plus 12 is 7, plus 20 is 27. So there are points at negative 1, 27. So those are my two horizontal tangents there. Part C, values of a and b that make the function both continuous and differentiable. Okay? I know that in order for the function to be differentiable, then I need the limit from the left at 3, which is going to be 3 plus 18c, to be equal to the limit from the right, which in this case at 3 is going to be negative 9d minus 3c. And then if I combine some like terms here, I can get, well actually I'll hold off on that. The second piece is I need it to be differentiable. So I got this from the continuous part. Now I need the differentiable part. So my derivative is 1 plus 4cx, came from the derivative there, 4cx. I'm going to put in 3 there, so I have 4cx becomes 12c equals negative 2 dx. But I'm going to put in 3 again, so negative 2 dx becomes negative 6d minus c. So that's getting from the differentiable part. So now I have the system of equations, and I can go ahead and I can solve that system. And I'm not going to go through the additional work here to solve the system, but I would solve the system. And what we end up getting is that d equals 2 and c equals negative 1. So there's my answer for that particular question. Okay, letter D asks about the normal line to the curve, and that curve is defined symbolically. I know anytime I'm looking for a tangent or a normal line, I'm always starting with my point-slope form. And let's see what information I have right away here and what I need to find. It says that x equals 2, so I know I'm going to plug in x minus 2 there. I know I need a derivative for f prime of x, so that's going to be g prime of x times f of x plus f prime of x g of x. And I'm looking for that derivative at 2. So g prime of 2 is 3 times f of 2 is 1. F prime of 2 is 2. And g of 2 is 3. So that's going to get me 9. But it wants it to be normal, so my slope is going to be negative 1/9. And then lastly, I still need the y-coordinate. So my y-coordinate is going to come from g of 2 times f of 2. Back from the original function, g of 2 is 3, f of 2 is 1, so that's going to be y minus 3. And there's my normal line. Letter E, my definition of the derivative, I see that very quickly as f of x minus f of a over x minus a. And so really what this question is asking for is, if the function is cosecant of x, then what is the derivative? And more specifically, what is that derivative at 4 pi over 3? Derivative of cosecant is negative cosecant x cotangent x. So now I have a problem that is an exercise in the unit circle. The sine of 4 pi over 3 is negative root 3 over 2. So that's going to become negative 2 over root 3. And then cotangent is x over y. So that's, again, negative 1/2 over negative root 3 over 2, which is going to simplify down to negative 1 over root 3. So I have the negative cosecant, so it's going to turn positive. Final answer, negative 2/3. Again, why negative? Because it was negative to begin with, and then my cosecant in quadrant 3 is negative. Cotangent in quadrant 3 is positive, so that should be positive 2/3 there. All the signs should end up canceling each other out. Letter F here talks about tangent line to the curve. Now I'm working with my chain rule, once again symbolically. So again, tangent line, no problem. X-coordinate is 3. So f of 3 is g of 9, and I'm told that g of 9 is negative 2. Again, f of 3 is g of 9, and I'm told what g of 9 was equal to. So now the only thing I still need is my slope, which is going to come from f prime of x. And from the chain rule, I get g prime of x squared times 2x. So at 3, I get g prime of 9 times 6. G prime of 9 is 3. 3 times 6 is 54. And there's my tangent line. Last problem in this case is letter G, where I have a 1, 2, 3, 4 functions combined symbolically. This is a nice little chain rule problem here. So I'm going to end up taking 4 derivatives, multiplying them all together, and keeping the compositions carried through. And all that's times 3x squared.